Hello friends, in the series of videos about matrix operations, this is part 1 where we would be introducing matrices, the rectangular array at the heart of matrix operations. We would be discussing in this video the definition of the matrix, transpose of a matrix and types of matrices. What is a matrix? Matrix is a rectangular array of numbers having rows and columns enclosed by pair of brackets. For example, this is a matrix where you have 4 rows and 3 columns and we've enclosed it by a pair of bracket. This is another example of matrix where we've enclosed it by a pair of bracket and we have 3 rows and 2 columns. So you can have a matrix having any number of rows and columns. For example, this is also a matrix. This is also a matrix, and this is also a matrix. So let us now discuss what do we mean by order of a matrix. So as we've seen earlier that a matrix has rows and columns. So if a matrix has m rows and n columns, we call it as m into n matrix. And m into n is termed as order of the matrix. For example, if you see this matrix has 4 rows and 3 columns. So the order of the matrix is 4 into 3. So we will call it as a 4 into 3 matrix. Let's take one more example. For example, this matrix, you have 3 rows and 2 columns. So this is a 3 into 2 matrix. In this matrix, you have 3 rows and 1 column. So this is a 3 into 1 matrix. So this first number, which is called as m, it represents row, and this second number, which we call as n, represent column. So let's see a general form of a matrix. So a matrix of order m into n means which is having m rows and n columns is represented generally like this. The matrix is denoted by capital letter always, and the elements of the matrix, these inner numbers, are known as elements of the matrix. They are represented by small numbers. For example, this A11 means this is the number which is in first row and first column. For example, this 832 means this number is in third row and second column. So this matrix can also be written in a more concise form as A is equal to Aij m into n. This is one way of the representing this general form of a matrix. M into n means number of rows and number of columns, as we've discussed. Let's take this example. We have to find out A34, A24, A43 and A25 in the following matrix. A34 means third row and fourth column. So this is 1, 2, 3. This is third row and this is fourth column. So at the intersection of third row and fourth column we have 8. So here A34 is 8. Then A24. So second row and fourth column. and this 2. And then A4 3, fourth row, third column, minus 2. A2 5. So this is second row, but you don't have any fifth column. So you don't have any number in this matrix representing A2 5. Now let's see, what do we mean by transpose of a matrix? If the order of any matrix A is m into n, means m rows and n columns, the order of its transpose, A transpose, we write it as AT, or at times we write it as A dash, A prime. We call it A transpose. Then it becomes n into m. Let's take this example. This is B and this is B transpose. So how do we make a transpose of a matrix? The row becomes column. So you see the first row has become first column of the transpose matrix, and the second row has become second column. So when the rows become column, the resultant matrix is transpose matrix. Let's take another example. A small matrix, say 2 minus 3 4 6. Let's say this matrix is B. What would be its transpose? So the rows, they become columns. So 2 minus 3. This was written horizontally row. Now we are writing vertically as column. And then 4 6. So very simple. When you write the rows as columns and columns as rows, that becomes your transpose matrix. Now we will discuss about types of matrices. So some of the most commonly used types of matrices are vectors, row and column matrix, zero matrix or a null matrix, singleton matrix, horizontal matrix, vertical matrix, square matrix, and these are the variations of square matrix: diagonal matrix, scalar matrix, unit matrix, symmetric matrix, skew symmetric matrix, and triangular matrix, which is also a variation of square matrix. It has upper triangular matrix and lower triangular matrix. So let us discuss them one by one. First, vector matrix, row and column matrix. So if a matrix is having only one row, we call it row matrix. For example, this 7 5 9, you just see it is having only one row. This is a row matrix. If you write 2 4 8 9 11, this is a row matrix. So if a matrix has only one column, then we call it column matrix. So these are also known as row vectors and column vectors. You just say that it has only one column but four rows. So if I had to write order of this matrix B, the order would be one row 1 into 3 column. If I have to write order of this matrix A, so it has 4 rows and 1 column. So order is 4 into 1. Another type of matrix is zero matrix, or we call it null matrix. When all elements of any matrix are zero, we call it zero matrix. Very simple. So you just see all elements are zero here. Singleton matrix. If we have a matrix which is having only one number, we call it singleton matrix. For example, this matrix is having only one number, only one element. This. Then horizontal matrix. So if a matrix is having more number of columns then rows, we call it horizontal matrix. You just see if n is greater than m, n means number of columns is greater than m. So here you have 1, 2, 3 columns, while you have 2 rows, and the order is 2 into 3. So you just see n is greater than m, right? So this is a horizontal matrix. Similarly, we have vertical matrix. When m is greater than n, means number of rows are greater than number of columns. So you take this example. Here we have 4 rows, 1, 2, 3, 4, and 3 columns, 1, 2, 3. The order would be 4 into 3. So this is a vertical matrix because it has more number of rows than number of columns. M is greater than n. Then we have square matrix. So in a square matrix, the number of rows and columns are equal. M is equal to n. So you just see, here we have 3 rows and 3 columns. So we call it a square matrix. In this matrix, we have 4 rows and 4 columns. So this is also a square matrix. So you can have 2 by 2 matrix, 3 by 3 matrix, 5 by 5 matrix, 6 by 6 matrix, right? So whenever we have number of rows equal to number of columns, we will call it a square matrix. For example, this also. Then a diagonal matrix. So in a square matrix, if all elements except the principal diagonal, they are 0, it is called a diagonal matrix. For example, this is a diagonal matrix. This is the principal diagonal. What is principal diagonal? If you see, from top left hand corner, it goes to bottom right hand corner. We call it a principal diagonal. So this is A11, this is A22, this is A33. So what is principal diagonal? Where I is equal to j, 1, 1, 2, 2, 3, 3, right? So in a square matrix, if all other elements except principal diagonal are 0, we call it a diagonal matrix. Another example of diagonal matrix. One more example. But you see, in all of them, principal diagonal is there and all other numbers are 0. Principal diagonal is there, all other numbers are 0. Then scalar matrix. So a scalar matrix is also a square matrix and it is a diagonal matrix where all elements of principal diagonal are equal. So we call it scalar matrix. Let's take this example. So it is a special type of diagonal matrix. All elements are same, 7, 7, 7. Just say -3, -3, -3. So if all elements of principal diagonal are equal, then it is scalar matrix, 5, 5. Rest elements are 0. So scalar matrix is a special type of diagonal matrix. Then we have unit matrix or identity matrix. So unit matrix is also a diagonal matrix, and where all elements of principal diagonal are 1. We call it unit matrix or identity matrix also. You just see this is a diagonal matrix. All elements are 1. So all elements of principal diagonal, please do understand the principal diagonal. Elements of principal diagonal are 1. 1. Rest are 0. So this is unit matrix. So when we will learn matrix multiplication, we will see when we multiply unit matrix by any other matrix, you get the same matrix. Then symmetric matrix. So a matrix is a symmetric matrix if A is equal to A transpose. The transpose of matrix is equal to the original matrix. For example, this. If you take transpose of this, let's take transpose. We've learned what is a transpose matrix if you make column as row or row as column. So I am making this first row as first column 7, 4, 8. Then second row as second column 4, 3, 2. Then third row as third column 8, 2, 9. This is your A transpose. Now just see, this A transpose is same as A 7, 7, 4, 4, 8, 8, 4, 4, 3, 3, 2, 2, 8, 8, 2, 2, 9, 9. So we will call it a symmetric matrix. So whenever we take transpose of a matrix and the resultant matrix is same as original matrix, that is known as symmetric matrix. Skew symmetric matrix. So we call a matrix as a skew symmetric matrix if A is equal to minus A transpose. We saw in the symmetric matrix when A is equal to A transpose, we call it symmetric matrix. When A is equal to minus A transpose, we call it skew symmetric matrix. For example, here we have A and let's take A transpose. So when we'll make transpose of it, the first row will become first column. So we will have 0, 4, 8. Second row will become second column, minus 4, 0, minus 2. And third row would become third column, minus 8, 2, 0. And what do we need? We need minus A transpose. So let's make it minus A transpose. So if you put minus, these signs of the elements would change. So 0 would remain 0, minus minus 4 becomes 4, minus minus 8 becomes 8. 4 becomes minus 4, 0 remains 0, and 2 becomes minus 2. 8 becomes minus 8, 2 becomes, minus 2 becomes 2, and 0 remains 0. So what has happened? We've reached back to the original matrix A. You just see 0, 0, 4, 4, 8, 8, and similarly the other elements. So what has happened is A has become equal to minus A transpose. So whenever you have principal diagonal 0 and the elements are in such a way that if you take minus of A transpose, then you get the original matrix back. We call it skew symmetric matrix. Then we have triangular matrix, and it is of two types, upper triangular and lower triangular. So we call it a triangular matrix where elements above or below the principal diagonal are 0. It is a square matrix, no doubt. Just see this upper triangular matrix. So elements below the principal diagonal are 0. So if Aij is equal to 0, where I is greater than j, means you just say this. This is A to 1. I is greater than j. This is A 3 1. I is greater than j. This is A 3 2. I is greater than j. So whenever we have I greater than j and the numbers or elements are 0, that is upper triangular matrix. Similarly, we have lower triangular matrix, but the numbers are 0 here. Whenever we have I less than j and number are 0. For example, this is A 1 2. Here I is less than j. This is A1 3. I is 1, j is 3. So I is less than 3. This is A2 3. I is 2, j is 3. 2 is less than 3. So whenever we have the I less than j and the elements of the matrix are 0, we call it lower triangular matrix. This is all about the introduction of matrix. Thank you very much for watching.